Today's topic is number system. In number system, usually there are four types: decimal, binary, octal, and hexa. Decimal is radix value is 10, binary's radix is 2, octal's radix is 8, and hexa radix is 16. So, as decimal's radix is 10, you can represent it from 0 to 9. Binary's radix is 2, you can represent binary number with zeros and ones. As octal's radix is 8, you can represent an octal number from 0 to 7. And hexa's radix is 16, so you will represent it from 0 to 9. After 9, it will be A, B, C, D, E, F. A's value is 10, B is 11, so on till 15. So you can represent an hexa number from 0 to 15. Why do we need 4 different types in a number system? Decimal is understandable by humans, whereas binary is understandable by machines, computers and all. And we use octal and hexa because it will be easy for us if we convert a binary number to octal and hexa. If you convert a binary number to decimal, it is not readable, like there will be complex in readability, and it will be easy if you convert it into octal and hexa. I'll show you how. So first we'll take a decimal number. We can use only 0 to 9, so we'll take 125. As it is decimal, we need to mention its radix as 10. So we'll convert it into binary, octal and hexa. First we'll convert from decimal to binary. Its radix is 10 and its radix is 2. You all know successive division, right? To convert any number from decimal to binary or octal or hexa, you need to use successive division or successive multiplication. As of now, you need to use only successive division. I'll tell what is the case when you need to use successive multiplication. So you need to divide with this radix value because you need to convert it into binary. So you need to divide it, the number, with 2. So if you divide it with 2, here quotient will be 62 and remainder will be 1. You need to divide with 2 till you get the last possible value. Like you can't divide that number with 2. You need to divide it till then. So here it will be 31 and remainder is 0. Again if you divide it with the 2, here the remainder is 1. Again if you divide, remainder is 1. These are coefficients and these are remainders. Here it will be 1 and remainder also will be 1. So if you take like this is the binary number. 1, 1, 1, 1, 1, 0 and 1. So this is the number. If you convert 125 decimal into binary, this will be the output. And next, now we will see how do you convert any decimal number to octal. Its radix is 8. So let us consider the same example 125 and divide it with 8 because you need an octal number from decimal number. Its radix is 10. So if you divide it, it will be 1 and 5 and the remainder will be 5. And again if you divide it with 8, it will be 1 and the remainder will be 7. So if you take like this, it will be 175. Decimal 125 is 175 in octal. And now we will see how do you convert any decimal number to hexa. Its radix is 10 and its radix is 16. So if you convert it, it will be 7. 16 sevens 112 and the remainder will be 13. So if you take any hexal number, you need to represent it from 0 to 15. After 9, there will be no numbers. It will be A, B, C, D, E, F. So yeah, 10 will be A, 11 will be B, 12 will be C, so on, F will be 15. So 13 will be D. So this will be replaced with D. So it will be 7D in hexa. 125 in decimal is 7D in hexa. Let us take this number as an example, which is in binary. How do you convert it into decimal? So this will be the formula. Now I will tell what is P and Di and R. P is number of digits left to this radix point. So there are 4 numbers. So P value will be 4. And N is number of digits right to this radix point. So there are 2 numbers. So it will be I equals to minus 2. And Di is these numbers. Each time you need to take one number with the formula. As I is iterations, each time you need to, for each iteration you need to take one value using this formula. And R is radix. We are in binary number, so our radix will be 2. So if we are using this formula, I iterates from minus 2 to 3. D I R power I. Radix is 2. Power I mean I iterates from minus 2 to 3. Here also it iterates from minus 2 to 3. Now if we consider it, we need to come from this side, minus 2. After dot it will be minus 1, minus 2. So we are starting from minus 2. We need to start from this 1. So it will be 1 into, what is our radix? Our radix is 2. Power I mean minus 2. We are in, our iteration is in minus 2. Plus it will be minus 1. 0 into our radix is 2. Power I mean we are in minus 1 iteration. Plus this 0. 0 into our radix is 2 and we are in iteration 0. Plus this 1. 1 into 2 power. After 0 our iteration goes to 1. It will pass from minus 2 to 3. So plus we will go to this 0. 0 into 2 power 2 plus 1 into 2 cube. 1 into 0.25 plus 0 into anything is 0 plus 0 into anything is 0 plus 1 into 2 2 plus 0 into anything 0 plus 1 into 2 cube is 8. 1 into anything is anything, so it will be 0.25 plus 2 plus 8. So it will be 10.25 in decimal. This is how you convert any binary number into decimal. To convert any number to decimal, this will be the formula. Again, how do you convert octal number to decimal? Using the same formula, D equals to P power minus 1. So let us take 175 octal number and convert it into decimal. So okay, there is no radix point, so let us consider like this. So right to the radix point there are no numbers which we created, so minus n value will be 0, and left to the radix point there are 3 numbers, so it will, p value will be 3. So the formula will be 3 minus 1, I equals to 0. D mean this number. For every iteration you need to take one number, and R is 8. As we are in octal number, our R value will be 8. So I iterates from 0 to 2. We consider starting from 0, take this number 5 into 8. Our radix is 8 power 0 plus 7 into 8 power 1 plus 1 into 8 square. Anything power 0 is 1. So 5 into 1 is 1 plus 7 into 8 plus 8 8 is 64. Anything into 1 is anything, so it will be 5 plus 7 8 is 56 plus 64. So it will be 61 plus 64, 125. And see, here we took decimal value 125, and if we convert it into octal we got 175. Now using this formula we converted octal 175 number to decimal, which is 125. So any number, if you need to convert it into decimal, you need to use this formula. And let's take hexa number and convert it into decimal. Let us consider 70 hexa number. And after radix there are no points, so let us consider 0. And right side of radix there are no numbers, and left side to the radix point there are 2 numbers. So p equals to 2, n equals to 0, as there are no numbers after the radix point which we added. So I equals to 0 to p minus 1, that is 2 minus 1, that equals to 1. So I iterates from 0 to 1, and now our radix will be 16. So it will be number d into 16 power 0 plus 7 into 16 power 1. What is the value of d in decimal? It is 13. 13 into 16 power 0, anything power 0 is 1. 13 into 1 plus 16 sevens, 112. So it will be 13 plus 112, which is 125. Before we considered a decimal number 125 and converted into hexa, that is 70. Now we took the same number 70, and using this formula if we convert, we got the same value 125 in decimal. So if you need to change from decimal to any value, that is binary, octal or hexa, you need to do successive division. If you want to change any number to decimal, that is binary to decimal or hexa to decimal or octal to decimal, you can use this formula. Binary number to octal and hexa. Octal is 8 and hexa is 16. So let us consider this binary number 11101.02, which is in binary, so we need to represent it with 2. And let us consider hexa, how to convert it into hexa. 16, no, it's radix value. So you need to take a group of numbers in which each group should have 4 numbers. So after radix point, for hexa you need to take group of numbers, in each group you need to have 4 numbers. For octal you need to take group of numbers, in each group they should have 3 numbers. So after this radix point you are not having 4th number, there are only 3 numbers, so you can't make it a group. So we will make it group by appending 0 on its right hand side. So now we can make it one group, that is 0 1 1 0. And after radix point we need to make these 4 a group, 1 1 0 1. And here there is only 1, so you can't make it group. Let us append 3 zeros to its left hand side. So it is 0 0 0 1 mean 1, 1 1 0 1 mean 13, which is D point, 0 1 1 0 means 6. So it is 6. 1. So your hexa number is 1D.6. If you convert this binary number to hexa, it will be 1D.6. So now we will see how do you convert the same binary number to octa. Its radix is 8. So before we took a group of 4 numbers, now we need to take a group of 3 numbers, because its radix is 8. So it will be 0 1 1 101. Here there are only two numbers, so you need to append 0 to his LSB side. So it will be 011. 011 mean 3, 101 mean 5, 011 mean 3. So it will be 35.3 in octal. Now we will see how to convert an octal number to binary and hexa to binary. Let us consider this octal number and how do you convert it into binary. So here what did we do for octal number? We paired three binary numbers, three binary bits we paired. So here we need to represent each decimal number, like each number, into three binary bits for octal. 3 mean, how do you represent 3 in binary? 0, 1, 1. How do you represent 4? 1, 0, 0. And 5, 1, 0, 1. Point. How do you represent 6? 1, 1, 0. 7, 1, 1, 1. 4, 1, 0, 0. So it will be 1, 0, 0. 1, 1, 1, 1, 0. Point. This 1, 0, 1, 1, 0, 0, 0, 1, 1. This will be the number in binary. In the same way, if we consider a hexadecimal number and if you convert it into binary, here what did we do? We paired 4 binary bits to form a hexa number. So we need to represent each number with 4 binary bits to get this hexa number to binary. So value of C is 12. So how do you represent 12 in 4 numbers? 8 plus 4. So this will be C value. And 4, 0, 1, 1, 0. 5, 0, 1, 0, 1. Dot. E is 14. 1, 1, 1, 0. D is 13. 0, 1. A is 10. 1, 0, 1, 0. So it will be ADE 54C2. This is ADE 54C. So it will be 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, dot 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. This will be your binary value. If you convert this hexa number to binary, this will be your value. As I told you earlier, if you need to convert any decimal number to any other form of number called binary, octal or hexa, you need to do either successive division or successive multiplication. We already did successive division, but what is the case where you need to use successive multiplication is, for example, if your decimal number is represented like this, if it is represented after decimal point like 0.7 and all, then you need to do successive multiplication. For example, if you need to convert it into binary, then you need to multiply with 2 till you get a whole number. So what is the case? You are not getting any whole number, then you need to stop it after you get 6 decimal points. So I will show it now. If you multiply 0.7 with 2, you will get 1.4. You didn't get a whole number. So you need to take, we'll say, right, floor value or seal value. Floor value mean, for example, 1.4 is between 1 to 2. So this will be your floor value for 1.4 and this will be your seal value for 1.4. Like seal mean top of 1.4, floor mean lower to 1.4. So this is 1.4. So you need to take floor value, that is 1. And for next multiplication, you need to take decimal point, that is 0.4 you need to consider. You need to remove this 1. 0.4 into 2, that will be 0.8. And this floor value is 0. And for next multiplication, you need to take 0.8 only. into 2, that is 1.6. Your floor value will be 1, and in this 1.6 you need to consider 0.6 into multiplication. It will be 1.2, and again your floor value is 1. In this you need to consider 0.2. 0.2 into 2 is 0.4. It will be 0 only floor value. Again consider this 0.4 into 2, that is 0.8, again 0. We already took 6 values and we are not getting a whole number, so we will stop this process. And if you consider from top to bottom, this will be your binary value. If you convert this 0.7 decimal value to binary, that is 101100. This value is after radix, right? So you need to consider dot, that will be 0.101100. Shall we take an example where we need to use the successive multiplication and successive division as well? Now let us consider an example where we need to use successive multiplication as well as successive division. So consider an example 125.7. It is in decimal. So how do you convert this number into binary, octal and hexa? So first we will consider binary. For this whole number which is before the radix point, we need to do successive division. For this number after radix point, we need to do successive multiplication. So we will do first successive division. For 125 in our previous video we already did. So it will be 2, 6, 2, remainder is 1, remainder is 0, remainder is 1, remainder is 1, remainder is 1, remainder is 1. We got a point where we can't divide this 1 with 2. Now division will be taken like this: 1 1 1 1 1 0 1 point. After point we have 7. We need to consider this 7 also into binary. As this value is after the radix point, we need to do successive multiplication for this with 2, because we need to convert it into binary. So it will be 1.4. You need to consider its floor value, that is 1, and in this you need to take only 0.4 for the next multiplication. This will be 0.8, floor value is 0, and consider this 0.8, it will be 1.6, and floor value is 1, and in this 1.6 you need to consider only 0.6 for the next multiplication. It will be 1.2, floor value will be 1, and 0.2 into 2 0.4, that is 0, and 0.4 into 2 0.8, that is 0. So if you consider this multiplication from top to bottom, it will be 101100. So this is the number, binary number, if you convert this decimal number to binary. And let's also see for octal and hexa. For octal, you need to divide it with 8 ones, 5, and remainder is 5. Again if you divide, remainder will be 7. It will be 175 point. And we need to, this 0.7 is there, right? This 0.7. If you convert this 125 decimal value to octal, it will be 175. You need to also consider this 0.7 value. If you consider this 0.7 value, it will be 0.7 into 8, because we are converting to octal and we need to use 8 number. If you do like this, it will be 5.6, and your seal value will be 5, and you need to consider 0.6 for next multiplication. It will be 4.8. Floor value will be 4. Here floor value will be 5, and you need to consider this 0.8 for the next multiplication, that will be 6.4, floor value will be 6 and 0.4 into 8, that will be 3.2, floor value will be 3 and 0.2 into 8, that will be 1.6. Floor value is 1, again consider 0.6 into 8, again 4.8. So this 4 value is repeated, so we will consider like this, 5 4 6 3 1 into octal. Stopped it here because we got a repeated value 4 where it is already repeated here. So even if you consider, you will get the same repeating value from here, 4 6 3 1 4 6 3 1, you will keep on getting like this. So better you stop whenever you get a repeating value. And now let's consider this decimal value to hexa. We need to do successive division for this 125 using 16, where we will get it 7 and remainder will be D, 70 point, and this 0.7 is there, right? Multiply with 16, we will get 112, that is 11.2. Its floor value is 11, which is B, and consider this 0.2 for the multiplication, it will be 3.2. Floor value is 3, and again consider this 0.2 with multiply with 16, it will be 3.2. We got repeated value. If you want to continue, it will be like B333, so on. So better stop whenever you get one repeating value. After 3 you got 3, so stop it. So it will be B3 in hexa. So successive division should be calculated from bottom to top, whereas multiplication should be calculated from top to bottom. Hope you understand.